In 1965, two radio engineers at Bell Labs named Arno Penzias and Robert Wilson were trying to eliminate a persistent, low-level noise from their antenna. No matter what they did, the noise would not go away. They cleaned the antenna, they removed pigeons that had nested in it, they recalibrated their instruments. The noise remained, a faint, uniform hiss coming equally from every direction in the sky with a temperature of about 2.7 degrees above absolute zero. What they had accidentally discovered was the cosmic microwave background. The standard interpretation is that this radiation is the afterglow of the Big Bang, light left over from the moment, about 380,000 years after the origin of the universe, when the cosmos cooled enough for hydrogen to form and radiation to travel freely. Wave physics offers a different interpretation. In wave physics, the CMB is not a relic. It is the hum of the membrane in its present condition, produced continuously by three universal mechanical sources that have never stopped running. The first source is the thermal vibration of every knot in the universe. Every atom, by virtue of having a temperature above absolute zero, vibrates perpendicular to the membrane plane. That vertical motion sheds low-amplitude ripples continuously in all directions into the surrounding substrate. With matter distributed throughout the observable universe, this source produces a contribution to the background everywhere simultaneously. The second source is stellar radiation. Stars emit an enormous amount of energy. It floods the membrane continuously in all directions. The cumulative effect of that output from every star across cosmic time is a pervasive low-amplitude contribution that is simply always present. The third source is the tension equalization flow generated by every object moving through the membrane. As we discussed in the radiation video, every moving mass generates a bow compression and stern deficit. The continuous equalization of that differential sheds incoherent low-amplitude ripples into the surrounding substrate. Every object in the universe is in motion. Every one of them is contributing to the background. These three sources are universal. They have operated for as long as matter has existed, and they arise from the same basic tendency as the magnetic flow that results from motion through the membrane, the equalization of tension. They produce a background hum that over aeons has settled into a nearly uniform result across the sky. The uniformity of the CMB is not evidence of a singular origin event. It is evidence of the connected nature of all things in the universe. The analogy from the manuscript is apt. The CMB is to the cosmos what the faint thermal hiss of an idle snare drum is to a recording studio. The hiss is always there, produced by the thermal motion of the drum membrane itself. Striking the drum does not create the hiss. It simply adds an enormous amount of energy on top of it. The sun is the struck drum. The CMB is the hiss that was always present. There is one additional observation worth noting. Recent analysis of data from the Planck satellite has found a statistically significant reduction in the CMB temperature in the direction of nearby spiral galaxies, extending out to distances of 1 to 2 megaparsecs from the galactic center. In wave physics, this follows directly from the areal dilution mechanism. The membrane near a massive galaxy is more diluted than the membrane in a void, and a more diluted membrane has a lower equilibrium vibration frequency, appearing as a cooler CMB signal. No additional mass component is required. The Standard Model has no agreed explanation for this observation, and has tentatively attributed it to the presence of dark matter halos. In the next video, we will discuss the dimensional extrusion hypothesis. It is a basic principle of wave physics, but following its promise to higher dimensions can also lead us into uncharted territory.